With people, sanibonani. Makuyabala. Now, determining the equation of a parabola. Now, we are going to have two cases in terms of determining the equation of a parabola. Now, the first case, it's where we have a turning point. So, when you have a turning point and another point in a graph, turning point and a point in a graph, which equation do we use? We use this equation here. So where we have y is equals to a into x plus p all squared and then plus q. This is the equation that we use. And then turning point, if now your turning point, specifically your x of a turning point, if it's negative, like this one is negative p, you put it inside the bracket as positive. Now, if your x of your turning point, let's say my x of a turning point here was p, let's say p maps to minus q. That's another x of a turning point. You're going to put it inside here as y is equals to a into x. Now, this is going to be what? It's going to be minus p because here it's positive. And then all squared. And then this doesn't change. If it was negative here, it's going to be negative q. If it was positive here, it's going to be positive q. This one doesn't change, just remain as it is. It's very, very important to understand that. And then the point that you're going to have in a graph, y corner, you're going to put it here, and x corner, you're going to put it here. And then after that, you're going to solve this a value because at the end of the day, our aim here is to find the a value. Now, that was a case where you have a turning point. Now, if you're having a case where you are having the x-intercept, now, x-intercept is going to be x1 and x2. And another point in the graph again. It's very, very important. x1, x2, which is your x-intercept. And then you are going to have a point in a graph. Now, your x1 is going to be here. X2 is going to be here. Again, this is the equation that you use when you are having your x-intercept. Now, x and this y is a point that you are going to have in a graph. So x and this x is where you substitute a point in the graph and also this y. Again, the aim in all of these things is to find this value of a. Hopefully, we are getting each other. Now, coming here, determine the equation of the following parabola. Now, in this case, we are having your x-intercept. So, negative 1 and 3, and then point in a graph. In this case, is negative or is 0 maps to negative 6. As it in this case, it's a y-intercept, but it doesn't have to be a y-intercept. But x2, x intercept, and a point in a graph. So here we're going to use y is equals to a into x minus x1 and then x minus x2. And then now let's substitute. A point in a graph is this one. So it's negative 6 is equals to a into my x in the point of a graph. It's going to be 0. And then minus into minus 1 and then 0 and then minus 3. Then from here minus 6 is equals to or minus 3a, and then we divide it by minus 3. We divide it by minus 3, and my value of a here is going to be equals to 2. Again, my value of a is positive and it's making sense because my graph is facing upward. So your value of a was supposed to be positive. Now from here, we're going to say y is equals to substitute. Now the value of a is going to be 2 into now x. Since this one again it's negative here, you put it inside here as what? As positive. So it's going to be positive 1 all squared. Not all squared. Why I'm writing nonsense? and then into x again, since this one is positive, so it's going to be negative inside here, and then from here it's going to be 2 into, then we open the bracket, so it's going to be x squared minus 3x and then plus x and then minus 3 and then equals to 2 into x squared and then minus 2x and then minus 3 and then equals to, and then with times we're going to have 2x squared and then minus 4x and then minus 6, and then this is going to be our equation of a parabola. Now, coming to these cases where we are having a turning point. Now, having a turning point, remember, we are using y is equals to a into x minus p squared and then plus q. Again, p and q are your turning points, and x and y are the any point that we have in the graph. In this case, that any point is this one, where you have 0 maps to 7. So we're going to substitute that point into 1, so it's going to be 7 is equals to a into, then the value of x is going to be 0. Now again, since this one it's negative here, we're going to put here as what? As positive, so it's going to be positive 2 and then all squared, and then we're going to have minus 1, and then from here we take 1 to the other side, then we're going to have 8 is equals to, and then this one is going to give us 4a, and then we divide it by 2, we divide it by 2, not 2, 4, we divide by 4, we divide by 4, and then my value of a is going to be what? Is going to be 2. And then from here, again, your value of a is going to be, it's not mine, the equation is going to be equals to a into 2 and then into x plus 2 all squared and then minus 1. And then again, you're supposed to write this in the form of is equals to a x squared plus bx plus c. Now coming to this one, again, y is equals to a into x minus p squared. Not p squared. Squared and then plus q. Then from here, again, our turning point, we are having this one as 3 maps to 0, and the point in the graph where we have 5 maps to 2. Then my y is going to be 2 is equals to a into my x of that point is going to be 5. And then again, since this x here, it's positive, you put inside here as negative, so it's going to be negative 3, then all squared, and then my q here, which is the y of a turning point, is 0, so it's going to be plus 0. Then from here is 2 is equals to 5 minus 2, 5 minus 3 is 2, and then all squared is 4, so it's going to be 4a, and then divided by 4, we divided by 4, and then my value of a is going to be 1 over 2. Then from here, you go to your equation, it's y is equals to 1 over 2 into x. Now again, x minus 3 and then all squared. We don't have the value of q, then you're going to leave it like this. Your value of q, basically, it's 0. It's not like we don't have it. And then from here, you take this to this form, where y is equals to ax squared plus bx and then plus c. Then let's do this last one. Again, same form. So y is equals to sorry, not this one, because we're having a turning point. So y into x minus p and then plus q. Again, there is another way of doing this thing. If you saw that this one here is a midpoint of these x-intercept, so we're going to find this one, which is gonna become negative 2. Then you're gonna use the x-intercept one, but still fine. If you didn't see that one, you can use this one. There's nothing wrong with that. Now we're gonna take this as my turning point, which is 0 maps to 4, and this is going to be my point in a graph, which is going to be 2 maps to 0. Then from here, we substitute. So the y in the graph, because this y and x is the point that you are having in a graph, in this case is this point. So my y is 0, and then is equals to value of a, and then the x in the graph, which is 2, and then going to now your turning point, my x here is 0, so it's minus 0 all squared. Then my q is 4, and then plus 4. Again, take 4 to the other side, so it's going to be minus 4 is equals to, this one is going to give me no positive 4a, then we divide by 4, we divide by 4, then my value of a is going to be negative 1. Then from here it's going to be y is equals to negative into x, and then basically x minus 0 all squared, and then plus 4, which is basically a negative x squared plus 4, which is, this is going to be your equation of a parabola. Thank you so much guys for watching. MagebaMaths.